Okay, we will get started. I hope everybody can hear me. Hello, ladies and gentlemen, wherever you are in the world. And welcome to this ABB webinar on measurement of water-stable isotopes. This webinar is a second part of a series of 3 webinars. So the first part was given in July. Focusing about general aspects of the ABB LGR offering for water-stable isotopic analysis. And today's webinar will focus on hydrology applications. And I'm really looking forward to that because you will see there are quite a number of applications in the world of hydrology. And you will also see in the end by the number of references that we can supply, and it's not an exhaustive list. There are lots of hydrology applications. So I'm really looking forward to that. So this webinar today will be given by my 2 colleagues, Marjolaine Arsenault, who is an application specialist at our Quebec City factory, and Susan Fortson, who is a product manager at our San Jose, California factory. So I have to inform you before we start the webinars that this webinar will be recorded, is being recorded actually. So the recording will be made available afterwards, and you can share it for colleagues or customers who might not have been able to join. I will also ask everybody to mute their microphones. I think it's already done from what I can see on the control. And we will, at the end, so the presentation, there will be a couple of several sections in the webinar. You will see we will talk about first general what is hydrology and examples of hydrology applications. Then Susan will give us details on the software, on the isotopic water analyzer software. She will explain the difference between a high throughput and a high precision mode, and she will explain how you typically run a sequence of analysis by interleaving standards with samples. And then there will be a conclusion with some bibliography shown by Marjolaine. And at the end, we will keep some time for questions and answer session. So you will that will be the time for you to unmute your microphones or send your questions by chat. Should you not have enough time to address your question today during the upcoming hour, feel free to send us an email afterwards. Our email addresses will also be displayed at the end of the webinar. With that, I will hand over to Marjolaine. Marjolaine, you might want to minimize the window on the bottom right of your screen. Yeah, exactly, because it's exactly, thank you. So with that, I will hand over the presentation to Marjolaine, and I hope everybody will enjoy this presentation. Up to you, Marjolaine.
Hello, everyone. So thanks for joining this part 2 of our webinars about water-stable isotopes. So again, like Frederick said, we're going to talk about hydrology applications. So 99% of our customer buying water isotope analyzer are doing hydrology. So it's quite important field. So first, what is hydrology? So we'll start with a definition from USGS. So it is the science that encompasses the occurrence, distribution, movement, and properties of water of the earth and their relationship with environment within each phase of the hydrologic cycle. So you have on the right an example of the hydrologic cycle. It includes evaporation and then precipitation, a stream flow, a ground flow, and it goes over and over again. There's many pathways. It includes rainfall, snowfall, polar ice caps, river, ocean water, soil. So it's quite a various number of point of study. Why do we talk about isotope measurement when we talk about hydrology? Because the isotope are fingerprint of water movement. So it's quite simple, actually. Isotopes have the same chemical properties, but different mass. Different mass evaporate at different rates, and it creates different ratio along the journey of water molecules in the hydrological cycle. The most abundant ones are O18 and deuterium. The ratio of one or the other are specific to different sources, rainfall, snowmelt, lakes, streams. So it allows to identify components of water stream, understand specific water flow generation mechanism, characterize the recharge rate and residence time of groundwater system, predict the migration of contaminant, and judge the impact of climate changes on water resources. Another thing you could follow is the D-axis, the deuterium excess. So this parameter actually reflects a relationship between delta deuterium and the delta O18. It's, as you see here, delta deuterium minus 8 times delta O18. This especially allow the measurement of environment condition of evaporation, vapor source, and it helps to identify climate changes, as we mentioned before. Another less abundant isotope is O17. It's lighter, thus evaporates more, so it's less abundant, but it will characterize general evaporation regimes, such as leaves and stream water evaporation, or past humidity from ice cores. The same way with you had deuterium excess, you have O17 excess. This way, it's a relation between O17 and O18. And why do we measure this? It's because it's not sensitive to temperature, and it's really effective to discriminate effects of condensation versus evaporation on the isotopic composition of water. We do have at ABB the option for these 3 isotopes. What are the challenges of isotopic measurement? So it depends on the source of the water we're measuring. So groundwater and stream water may contain visible particulates and would require sample preparation before analysis. Seawater, of course, it's contains salt, so it could have a salt buildup and accumulate over time in the analyzer. This is not, I'm not saying it will accumulate in our ICOS, but it's a general problem for all the system. Then we have glacier rivers. Of course, the main problem is the low temperature that could impact the field deployment. And finally, precipitation. Here we have water isotopes that are depleted. So because heavy isotope won't evaporate as much, so will occur more typically at a high concentration in liquid and solid, while when it's come to lighter isotope, it would be in gas phase. So what are the LG ICOS solution to all these challenges? First, ABB offers a variety of rugged analyzer options, including a field deployable portable analyzer, temperature stable benchtop model, and a dual mode of measuring liquid and vapor at the same time. User can easily switch between high throughput or high performance modes, and this we'll talk later about how to do it and what are the advantages of it. LG ICOS isotopic water analyzer can operate at a wide range of temperatures. So that would be for glacier, for example. Remote instrument access provide the opportunity to obtain and share data or diagnose the operation without being in a laboratory. So again, it's a field deployable system. If we continue talking about salt water, the analyzer is designed to measure isotope ratio of salt water. It can go up to a salinity of 4 grams per liter of salt. Although there's some tips, we're going to take some time here just to say that it's better to alternate clear standard without salt with salt water sample to prevent excessive salt deposition in the syringes. Of course, the syringe and the block heater heated injector blocks, have to be cleaned regularly. And then an additional heated injector block is included with each analyzer, so it prevents the downtime time due to cleaning. ABB has a wide range of water standard. We talked about it in the previous presentation. So it goes from depleted water to high enriched samples. We have a post-analysis software that simplifies analysis and enables highest performance. This will be covered by my colleague, Susan. It's the spectral contamination identification module, and it quantifies accurately and detects the presence of organic contaminants in water sample. Finally, when we talk about dirty sample, like a stream or groundwater, there's no need for sample preparation other than centrifugation or simply fine filter paper. There's no need to any chemicals, just to remove the suspended particles. Just come back to a particularity. So for the benchtop system with the auto injector, we mentioned the last time that it can inject about 800 injections per day. This is because each injection takes about 90 seconds. What's happened during this time? First, the removing of the previous injection from the measurement cell. Then we fill the cell with dry hair. We remove the dry hair with the contaminant from the cell. We inject 1 microliter of the sample in the cell. It evaporates completely. And finally, we measure the optical absorption spectra. We suggest that samples are intervene between 3 standards of a similar isotopic range. For natural rainwater, you say a standard method would be 6 injections per sample, so about 9 minutes, followed by water standard with in a similar manner. This measurement rate will lead to about 130 samples per day when paired with auto injector. So this leads us to the part of my colleague. So I pass the floor to Susan Fortune.
Hello, everyone. Before we discuss the post-analysis software, we're going to talk about the injection patterns of the liquid water isotope analyzers. We recommend running the analyzer in a pattern where unknown samples are interleaved with standards that have a known isotopic value. An interleaved run is defined as having standard and sample injection sets, which are measured in alternating order. So the user can either create their own run configuration, or we also have pre-installed example run configurations, which are built into the software. So they're used as starting points, which can define more complex measurement sequences. So here on the right, you'll see an example of an interleaved data set with rotating standards in between samples. You'll notice that each standard and sample injection group consists of 6 measurements. The first 2 injections, which you'll see in blue, those will be ignored. And then the following 4 measurements will be averaged. And those are the green ones you'll see in the first column. The run begins with 1 standard injection group, then followed by 4 sample injection groups. This pattern continues with 3 standards of different isotopic compositions. The ignored injections that you see in blue are the initial injections to be excluded each time a standard or a sample is changed. The purpose of this is to mitigate analyzer memory effects, regardless of whether the injection is good or not. They function basically as normal injections, but the measured data will be excluded by the post-analysis software. Next slide. So run configurations are dependent upon the customer's needs. So for example, some of our customers are interested in high throughput mode. That means they want to do more samples per day, while other people may be interested in a very precise measurement. For high precision, the same sample is measured multiple times and then averaged. On the left side of the screen, you'll see an example of a run configuration for high throughput mode. So in this case, sample 1 is injected 6 times, and the last 4 are measured injections. They're averaged to provide 1 data point. In this example, you'll see that 20 samples are measured. So for example, in between standards 1 and standards 2, you'll see sample 1s, 2, 3, and 4, and so on. Also listed here are the specs for high throughput mode. So for deuterium, it's 400 per meg, and oxygen 18 and 17 are both 100 per meg. However, on the right side of the screen, you'll see an example of high precision mode. In this case, similarly to the high throughput mode, they run it the exact same way, where sample 1 is injected 6 times, and the last 4 measured injections are averaged to provide 1 data point. However, this time the same sample is then repeated 10 times. Those 10 data points are averaged to provide a high precision value. So only 2 unique samples are measured in high precision mode, whereas in high throughput mode, 20 samples were measured. For the specs for high precision mode, you'll see that it's 200 per meg for deuterium, and for oxygen 18 and 17, it's 30 per meg. Next slide. Customers who are interested in measuring a wider range of isotopes can increase the number of injections to mitigate memory. For example, they can increase the number of injections for each sample and standard from, for example, 6 to 10. So if you refer to the table on the left, for a full natural range, the user chooses the appropriate standards. For example, VSMO, JISP, and SLAP, which can be purchased from IAEA, which is the International Atomic Energy Agency. And then to mitigate memory, they would actually need to increase the number of injections. So in this case, injections 1 through 6 would be ignored by the post-analysis software, and injections 7 through 10 would be used for processing. For the enriched range on the right table, the customer would use enriched standards, which you can purchase directly from us. Because the samples are enriched, a 1-to-1 interleave of standards in between each sample is recommended for additional referencing. Next slide. The post-analysis software is included with all of our liquid water isotope analyzers. It's a tool that's designed to provide a powerful and simple method of post-processing the data which was acquired by the analyzer. The post-analysis algorithm assumes that the analyzer's run configuration was set using standards that are interleaved with samples, as we mentioned previously. The software calculates these adjustments to the measured values of isotopes based on the difference between the known and then the measured values of the standards. And it then reports a processed value. It can be measured in any number of interleave samples. We do recommend standard sample grouping, but the post-processor software can accommodate other types of run configurations if necessary. Next slide. So listed below are some of the functions of the post-analysis software. So it can load standard data files, which for those of you that are familiar with the software is the F file. It performs all required standardization and processing steps. It exports the process data to easily readable text files. And from those text files, you can then load into Excel, for example, for easy data interpretation. It automatically checks for analyzer performance flags. So for example, if the analyzer produces a poor injection due to syringe instability or a leaky septum, temperature fluctuations, or a variety of other issues, the post-analysis software can use these filters to identify and alert the user of problems with the analyzer. It recognizes and tracks customizable internal controls. It provides several data filters. So for example, if the data is outside of the bounds of the filter, then the injection will be excluded from the calculations of the process data in order to provide the user with accurate results. And it also allows many different graphical views of the data, as well as being fully configurable. Next slide. One other feature of the post-analysis software is the spectral contamination identifier. So some water samples, particularly the ones that are extracted from plant material, can be contaminated with small molecules that have a terminal OH bond, alcohols are being an example. These molecules have an absorption feature in the same region of the optical spectrum that the liquid water analyzer uses to quantify the isotopic ratios. Examples of contaminant molecules can include methanol and ethanol. These can be generated in plant waters by the fermentation of plant sugars by naturally occurring yeasts. They are both difficult to extract using chemical filters. And also hydrogen peroxide, which could exhibit interferences as well. However, it can be removed much more easily. The post-analysis software is capable of identifying these spectral contaminations using spectral data columns recorded by the analyzer. The post-processor analyzes the data files to produce a metric that indicates the presence of contamination from either narrowband or broadband absorbers, which I'll discuss in a moment. This metric is compared to clean, uncontaminated standards within the data set. If there is a contaminated sample, as you'll see on the picture on the right, the ones highlighted in orange, the software will produce an interference flag, also known as INTF, to indicate the presence of the spectral contamination. This feature helps users to establish complete confidence in their measured results. Next slide. So the contaminating compounds can be divided into two categories of absorbers. Both of these absorbers produce measurement errors by altering the spectra in a way that is not modeled in the spectra fitting routine. So for example, we have broadband absorbers, such as ethanol. They change one or more of the offset, slope, and curvature of the base absorbance, which can impact the isotopic ratio. Therefore, the post-analysis software compares the measured baseline absorption of each sample spectrum to the average for the unassumed clean, uncontaminated standards. Narrowband absorbers, however, such as methanol, have a small narrowband peak to the side of one of the three water peaks, which can distort the fitting function, causing the area under the nearest water peak to artificially increase. The identification of this absorber is achieved by examining the spectrum fit residual in the spectral regions where there are no strong water absorbers. The fit residual is the difference between the measured spectrum and the spectrum calculated by the non-linear fitting routine. So it's expected to be very small in the regions between the water peaks. If a contaminant with narrowband absorption features is present, the fit residual will show a significant increase because the unknown peaks are not included within the fit model. One thing to mention is contaminated standards. So if the post-processor detects a possibly contaminated standard, the results may be invalidated since all the contamination flagging is based on the assumption that the standards are clean and uncontaminated. Next slide.
Thank you. Thank you, Susan. So if we summarize the advantages of ABB LGR ICOS technology, we already mentioned them, but it's always good to cover them again. So does not require any extensive consumable, trained personnel, high vacuum, or sample conversion like it would be for mass spectroscopy. It requires lower power, and the cost per sample analyzed is substantially smaller than competition technology. In addition to the benchtop measurement, the ABB portfolio includes some compact portable field deployable spectrometer, such as illustrated here in the yellow box. The ABB LGR ICOS water analyzer are rugged and designed to handle both natural and enriched water, as described by my colleague Susan. And finally, the user can leverage the precision and the speed of the instrument by coupling them with a benchtop auto injector we talked about many times here, to perform unattended injection pattern on multiple samples. And good news, in the future, we'll also release a portable auto sampling system that can be paired with the field deployable analyzer. Finally, here is a table to summarize that you can have either portable, benchtop, liquid, vapor, both liquid and vapor, 18 in deuterium all the time, but you can add 017. Some cases you can have 017 excess, D excess, and in case of vapor, you can measure the concentration of water. To conclude, here are some scientific papers featuring ABB solution. So I won't read them out, but you feel free to read them at your leisure after the presentation. They're all available. If you want them, just ask one of us, either Susan Fortune, myself, Frederic Despang, or simply at the ICOS application email box. Thank you for listening. I hope you enjoy it.
Thank you, Marjolaine and Suzanne. So we have time now for a Q&A session, questions and answers. So this is a time for people who want to ask questions to unmute your microphone, or which is the best way, or send your questions in the chat. So please feel free to ask your questions. We have our experts on the line. So for the moment, it looks like we're not having questions. Everything seems to have been very clear for everyone on the call. As I said earlier, okay, I see a question from Hans. Hans is asking if liquid analyzers, which tend to be leaky, can be quickly tested for a check. Not sure. You mean a leak test, Hans, I guess.
Let's see. So let's see, is there any way to do a quick check? So if you do a single injection and monitor the screen during the 30 measurements that the injection does, if you notice an increase in the water number density, then that will indicate a leak in the system. It shouldn't leak any less than 0.2 torr per minute. So you can time it. But generally, if the front end, meaning the transfer tube all the way to the injector heater block, is is tight, you shouldn't have problems. Also, you can try removing the transfer line as well and do an injection and cap the septum port and do an injection without water. You can also notice or watch the trend and make sure it's not increasing.
Thank you, Susan. Are there other questions regarding those applications and instruments? We have a question from Randy asking, what is the natural source of hydrogen peroxide contamination? I'm not sure where this would come. By the way, Susan, do we detect hydrogen peroxide with the SCI module? Because you mentioned it was easily removable.
Yeah, sorry about that. I was unmuted. I am not familiar with hydrogen peroxide, so I would actually have to look into that and get back to you guys.
Okay, we'll check with that. We'll check Randy on the source and we'll come back to you. Yeah, Doc confirms he is not aware of any natural source of hydrogen peroxide. I know in some sterilization processes sometimes those can be present, but no natural source, it seems. But we'll confirm that. We'll check that. Are there any other question? Difference between cavity ring down and ICOS, and which is better and why? Well, I mean, from the functional point of view, when it comes to isotopic analysis, I would say that one of the biggest difference for the end user is mainly the speed. The way cavity ring down spectroscopy operates requires some thermal and pressure stabilization of the cavity, and basically the throughput of the cavity ring down spectrometers is much lower than the ICOS technology. That's one of the biggest differences. Susan and Marjolaine mentioned the number of analyses which can do every day, up to 800 injections. It's not 800 samples, it's 800 injections. This number cannot be matched by cavity ring down spectroscopy instruments. It's much fewer, a few tens of samples per day and maximum. From the performance point of view, one of the issues, well, the way the spectra are recorded between cavity ring down and ICOS spectroscopy is also quite different. Basically, the laser for cavity ring down spectroscopy measurement is locked to successive modes. So basically, you don't have a continuous description of the absorption bands under the infrared spectrum. You have a very digitized spectrum, and which is okay as long as you don't have interferences. When you're running into interferences because you have only a limited subset of data points on your spectrum, you may miss interferences. Whereas with ICOS technology, we are doing continuous absorption, continuous wavelength scanning. So we get a complete profile of the absorption features in the spectrum, which makes it much easier for the algorithm to detect whenever you have a contaminant. So one of the consequences of that, when it comes to the differences between both technologies for isotopic water applications, it's the fact that for cavity ring down spectroscopy, you need to often to pre-treat your samples to evacuate interference, to eliminate interference, whereas with ICOS spectroscopy, as Marjolaine said, I mean, there is pretty much no sample preparation besides basic filtering. And then if interference are present in the sample, they will be detected, they will be flagged by the spectral contamination identification module. So we don't need to change, we don't need to pre-treat the sample and we don't need to alter the sample. And this is very important because when you do isotopic analysis, if you start pre-treating the sample with different techniques, you start generating fractionation issues. You start altering the isotopic ratios between the different isotopes. So this is probably, those are probably the two biggest differences between CRDS technology and ICOS technology. Are there other questions? I see, by the way, Marc-André, our colleague Marc-André came back regarding the impact of hydrogen peroxide, sources of hydrogen peroxide. And he found that it forms upon the elimination of natural catalytic action by substances contained in water. So it's elimination of catalytic phenomena. Seawater contains 0.5 to 14 micrograms per liter of hydrogen peroxide. So it seems to be a rather minimal impact anyway on isotopic on water applications. The most current contaminants that you might find in waters are ethanol or methanol, and which are detected and which can be corrected for by our software. We have a question from Florent Suzanne about syringe storage. Do you want to provide information on that?
Sure, I just sent a quick message, but I can speak as well. So typically what I do, if I want to store my syringe, I don't want it to dry out, because once it dries out, you can actually break it if the syringe becomes, if the plunger becomes stuck. So I like to take a clean vial of water, and then I'll take a cap that's already been pre-punctured, and I'll insert the tip of the needle into the syringe, and I'll pull all the way up to the 1.2 microliter mark, and lay the syringe down while it's in the vial. And that just keeps it wet and clean for the next time. There's also something that you can refer to in our customer user manual called NMP, and it's kind of like a lubricant that you could use as well for syringe storage or syringe cleaning as well.
Thank you, Suzanne.
You're welcome.
Do we have other questions, either on the instruments or the applications, hydrology applications? Okay. Okay, I do not see further questions. As we mentioned, the recording of the webinar will be made available, and also all people who receive the invitation for this webinar will receive a copy of the presentation. And you will see in the last slides there are some references. Maybe if you want to show again quickly, Marjolaine, some of the list of articles in the last exactly in the last slides. Again, it's not an exhaustive list. Those are just examples of some of our customers who have been using the ABB LGR instruments for hydrologic applications. And those articles, all the articles which are listed in this presentation, can be made available upon request if you contact one of us. There are more articles than the one we listed here, which have been published, but those are the ones for which we have a copy and we can share the copy with you. Bayu has a question on the difference in 17 OXS between ABB LGR instrument and Picaro. I think he's asking about the performance difference. As we will need to check on that and specification. I really don't know by heart the Picaro performance precision, so we will need to check this. But as Doug mentioned also, when it comes to difference between the ABB LGR instruments and the other technology instruments, one of the big difference, of course, is the ease of servicing. To my knowledge, only the ABB LGR instruments have a cavity that can be cleaned by the end users whenever this happens. And sometimes it may happen that you have a contamination even in the cavity, especially when you're handling dirty water. So ease of servicing is a very important point and a very key differentiator of the ABB instruments. We have had a number of customers who have been using our instruments, isotopic water instruments, in very challenging environments. A number of them are bringing their instruments to do measurements in ocean water. So they have some isotopic water analyzers on a boat somewhere in the ocean, and they have this possibility whenever there is excess contamination in the samples and in the hardware to clean the instrument and service themselves the instrument without having to return the units to the factory. This is a very big differentiator of our instruments compared to all other technologies, whether laser-based or not. Another point also which is worth mentioning is, as Marjolaine mentioned, we are offering portable isotopic water analyzers, either for water vapor. We have a version for water vapor, and we have a version for liquid water. So we are now bringing isotopic analysis to the field. And this is a very big, very significant advance, because until now, isotopic analysis had to be performed in a very controlled conditions in a laboratory. Now some of our